In the last video, we have seen three methods for solving a quadratic and the use of discriminant formula. Today, both of the skills will be used in a new setting. Now let's have a look at two questions from Cambridge past papers. Question 1. The straight line y is equal to x plus 5 meets the curve (2x square plus 3y square is equal to k) at a single point P. Find the value of constant k. One more question. Given fx is equal to x square minus 4x plus 8, find the values of x such that fx is less than 9. These questions feel like they are from different topics, but they have a very interesting connection, and Cambridge uses that connection to make some interesting questions for paper 1. We will solve both the questions at the end of the video, so let's build up to them. If you haven't watched video 1 on quadratics, please go watch it first. The concept will build up upon that. So let's discuss our first topic for this video, discriminant formula. And number of roots. We will understand this using three examples. So example 1 is, suppose we have a quadratic equation x square plus 2x minus 8 is equal to 0. We want to find the roots of this quadratic equation by using quadratic formula. From the last video, I know that the quadratic formula is given by minus b plus minus root b square minus 4ac divided by 2a. So if I apply quadratic formula in this context with the values of a, b and c as follows, then the value of root x over the roots is given by minus 2 plus minus 2 square minus 4 times 1 times minus 8 divided by 2 times of 1, which is minus 2 plus minus 2 square is 4, and negative 4 times negative 38 and negative 4 times negative 8 gives us 32. So the number inside square root is 36 divided by 2. We get minus 2 plus minus 6 divided by 2. So in this case, we will have two solutions, one with positive value of 6 minus 2 plus 6 divided by 2, which gives us 2, and one with negative sign of 6 minus 2 minus 6 divided by 2, which gives us negative 4. Notice that in this case, the number inside square root is a positive number, and in this case, we have two solutions. Now coming to example 2, suppose we have y is equal to x square plus 6x plus 9. Again, if I apply quadratic formula, so x is equal to minus b minus 6 plus minus 6 square minus 4 times 1 times 9 divided by 2 times of 1. So we get minus 6 plus minus 6 square is 36, 4 times 9 is 36 divided by 2. So we get minus 6 plus minus root of 0, that is 0 only, divided by 2. So we get minus 6 upon 2 minus 3. Notice that in this case, the number inside square root is 0 and we get only one solution in this case. Now, coming to the third example, x square plus 2x plus 6 is equal to 0. Again, applying the quadratic formula, we get minus 2 plus minus 2 square minus 4 times 1 times 6 divided by 2 times of 1. So we get minus 2 plus minus 2 square is 4. 4 times 6 is 24 divided by 2. So we have minus 2 plus minus root of minus 20 divided by 2. Now since the number inside square root is negative and square root of a negative number doesn't make sense in the real numbers, so in this case we will have no solution. It's not defined, so we will have no solution. So depending on the number inside square root to be positive, 0 or negative, we get different number of solutions for a quadratic. So this number inside square root, it's a special number. This is called discriminant and it is denoted with capital letter D. So we have discriminant as b square minus 4ac and we have three cases. So if D is positive, we have two solutions. If D is 0, we have a single solution of a quadratic, one solution. And if D is negative, we have no solution. Now we will discuss the next topic in this video, that is solving simultaneous equation when one linear equation and one quadratic is given to us. So simultaneous equations. So we'll discuss it through examples. So example 1, suppose a linear equation y is equal to x plus 2 is given to us and equation of a parabola y is equal to x square is given. We want to find points of intersection, or we want to solve this simultaneous system of equations. So what we can do is we can substitute the value of y from the first equation, from the linear equation, into parabola equation. So this is our first step, substitution. So we get x square plus is equal to x plus 2. Then the second step is we will arrange it so that on one side we have a 0. We'll bring everything to one side. So we get x square minus x minus 2 is equal to 0. So solving this system of simultaneous equation is converted into a problem of finding number of solutions or finding roots of this quadratic equation, and we already know three methods for solving it. So suppose I want to do it by factorization method. I want to find two numbers which add up to minus 1, that is the middle term, and the product of these two numbers should be same as product of 1 times minus 2, that is minus 2. Clearly I can see that minus 2 and 1 satisfy both the condition, since minus 2 and 1 add up to negative 1 and the product of negative 2 times 1 is negative 2. So this means the middle term minus x can be written as minus 2x plus x minus 2 is equal to 0. This implies from the first two terms I can take x common, so x times x minus 2. From the last two terms 1 could be taken common, x minus 2. Then this entire bracket can be taken common, so we have x plus 1 x minus 2 which is equal to 0. So solving the first bracket gives me x plus 1 is equal to 0. This implies x is equal to minus 1. Solving the second bracket gives me x minus 2 is equal to 0. This implies the value of x is 2. So these are my two solutions. Now after finding the x values, I would highly recommend to find the y values as well. Cambridge always award full marks for finding both the coordinates. So I can use my linear equation or quadratic equation to find the y coordinate. So by the given quadratic equation, y is equal to x square. This implies when x is equal to negative 1, then value of y is negative 1 square, which is positive 1. So this means minus 1 comma 1 is one of the solution, And for x is equal to 2, when x is 2, this implies y value is 2 square, which is equal to 4. This means 2, 4 is another coordinate pair which satisfy both the equations. So now let's discuss one more example based on this. Suppose we have x minus y is equal to 1 and x square plus y square is equal to 25. So first of all, we will try to rearrange the linear equation to make y as a subject. So we get x minus 1 is equal to y. After making y as my subject, I will substitute this in my quadratic equation. So this is the most important step where student loses marks. They try to substitute without making y as a subject. So after substitution we get x square plus x minus 1 square is equal to 25. If I simplify this, if I open the bracket, I get x square minus 2x plus 1, which is equal to 25. This implies 2x square minus 2x, bringing the 25 term to left hand side. 1 minus 25 gives me minus 24, which is equal to 0. This entire quadratic equation can be divided by 2. So we get x square minus x minus 12 is equal to 0. Again, the problem, simultaneous problem, is converted into finding solution of a quadratic. So we are looking for two numbers which add up to the middle term, coefficient of middle term minus 1, and the product of such two numbers, it should be the product of coefficient of x square times the constant term, so minus 12. Clearly two such numbers are negative 4 and positive 3. Since the addition of negative 4 plus 3 is minus 1, it satisfies the first condition, and the product of negative 4 times 3 is minus 12. It satisfies both the conditions. This means the middle term can be written as minus 4x plus 3x minus 12 is equal to 0. Using the same drill, from the first two terms x could be taken common. From the last two terms I can take 3 common. So this implies x plus 3 times x minus 4 is equal to 0. So either the first bracket is 0, so x plus 3 is 0, or x minus 4 is 0. So from the first equation I get value of x is minus 3, and from the second equation value of x is 4. This is not the final solution. We need to find the y coordinates as well. So using the linear relationship y is equal to x minus 1, this implies when the value of x is minus 3, then the corresponding value of y is minus 3 minus 1, which gives us minus 4. And when x is 4, so 4 minus 1 gives us 3, so 4 comma 3 is the second coordinate pair. The rule is always this: you substitute the simple equation into the complex one. So always substitute a linear equation into a quadratic one. Don't do it other way around, otherwise it's going to be very messy and it would be very difficult to untangle. Now let's discuss one more example. Consider y is equal to kx minus 1 to be a tangent to parabola y is equal to x square. Find k. So this is a Cambridge favorite way to combine two topics in a single question. So now if I substitute straight line equation into the parabola equation, we get x square is equal to kx minus 1. So rearranging everything to left hand side, x square minus kx plus 1, which is equal to 0. Now since this straight line is a tangent to parabola, we have only one solution. So it means the discriminant needs to be 0. So discriminant b square minus 4ac is 0. Now substituting the value of a, b and c, in this case a is 1, b is minus k, and c is positive 1 into the discriminant formula, we get minus k square minus 4 times 1 which is equal to 0. This implies k square minus 4 is equal to 0. This implies k square is equal to 4. This means the value of k is plus or minus 2. So this is a common point where a student makes a mistake while taking square root of 4. Students generally write only plus 2. They ignore the negative 2. It is also a possible solution since negative 2 square is also 4. Notice what just happened in this question. So we used substitution, discriminant formula, all of it in a single question. So this is how Cambridge paper 1 works. Topics never appear in isolation. They are always connected to each other. Now we will discuss our next topic, that is solving quadratic inequalities. Solving quadratic inequalities. So this is one of the topics that students find very challenging. They treat it as a simple quadratic. They find some values of x. Then there is a guesswork whether the values of x are more than a particular value or less than a particular value. This generally costs us some marks in the actual examination. So I will discuss a method which will make it more mechanical, so that there will be no guesswork involved while deciding the sign of inequalities. So let's discuss this method. So let's start with this example 1. X square minus 5x plus 6, it's greater than 0. So now we have a quadratic inequality. Instead of equal sign, we have greater than sign or less than sign. These are called inequalities. So in this case, first of all, I will treat this parabola. For the time being, I will treat this as a equation equal to 0 and try to find solutions for x. So we want to find two numbers which add up to negative 5, and the product of these two numbers should be 1 times 6 is equal to 6. Clearly, two such numbers are minus 2 and minus 3, which add up to negative 5, and the product of negative 2 times negative 3 is positive 6. So in this case, I can replace my middle term as minus 2x minus 3x plus 6 is equal to 0. From the first two terms, x could be taken common. From the last two terms, I can take minus 3 common. This gives us x minus 2, x minus 3 is equal to 0. Solving the first bracket gives us value of x as 2, and from the second bracket, value of x is 3. So these are my two solutions for this quadratic equation. Now I am going to sketch this parabola. I know it will feel like extra work, but it will take only 10 minutes and it will remove the guesswork regarding the inequality sign. So let's see how this works. So in this case, I found out that there are two solutions of this parabola, 2 and 3. So my parabola will be passing through these 2 points, 2, 3. And since equation of parabola is x square minus 5x plus 6, in this case, the value of a is 1, which is positive. So the shape of parabola will be like a U. It's going to be a upward parabola. So my parabola will pass through these 2 points, 2, 3, and it's going to be a upward parabola. Now from the inequality, I want my parabola to be positive, x square minus 5x plus 6. I want this to be greater than 0. So from the graph, anything above the x-axis is positive and anything below the x-axis is negative. So it means when the value of x is more than 3, my graph is positive. When the value of x is between 2 and 3, graph is negative, and before 2, graph is positive again. So this means for my parabola to be positive, x is greater than 3 or x is less than 2. Now let's slightly change the problem. Suppose we have x square minus 5x plus 6, which is less than 0. Now we have same parabola, same roots, only the sign of inequality is changed. Now I want my parabola to be negative. So I know that anything below the x-axis is negative. So it means the value of x should be between 2 and 3. So this is going to be my solution. In this case, my x is between 2 and 3. Notice the keyword here, and. So in the last two examples, we had same parabola, same roots, just the different sign of inequality. That's why the graph is important. It's not a choice, it's going to be our method. Let's discuss one more example based on this topic. Two x square plus x minus 3, which is less than or equal to 0. So for the time being, treat this as a equality or equation. So 2x square plus x minus 3 is equal to 0. To find solutions for x, I want to find two numbers which add up to the middle term plus 1, and the product of two such numbers should be 2 times negative 3, which is minus 6. Clearly, two such numbers are positive 3 and negative 2. Both of them add up to plus 1, and the product of positive 3 times negative 2 is negative 6. This means the middle term can be written as plus 3x minus 2x minus 3, which is equal to 0. From the first two terms, I can take x common. So x in bracket 2x plus 3. From the last two terms, negative 1 could be taken common. So in bracket again 2x plus 3, which is equal to 0. Then this entire bracket could be taken common. So 2x plus 3, x minus 1 is equal to 0. Solving the first bracket gives me 2x plus 3 is equal to 0. This implies 2x is equal to negative 3, taking positive 3 to the other side. Then we'll take 2 to the other side. 2 is in multiplication, it will go into division. So minus 3 by 2 is one of the solution. If I equate second bracket to 0, this implies the value of x is positive 1. Now we will do our sketching bit. So we have a parabola passing through minus 3 by 2 and positive 1, minus 3 by 2 and positive 1. And since the coefficient of x square is 2, which is positive, it's going to be a upward parabola. I want to find points where my parabola is less than or equal to 0. It's negative or 0. I know that between the roots, parabola is going to be negative. So my solution is going to be x is less than or equal to 1, greater than or equal to minus 3 by 2. Do not ignore the equal sign in this case. So whenever in the inequality you have less than equal to 0, a parabola less than equal to 0 or greater than equal to 0, and then in the final solution also we have equal to sign in the inequality. Remember the two questions I showed you in the beginning? Let's solve both the questions together. This is a 5 marker in Cambridge examination. Let's see how many tools we use to solve this question. So in this question, y is already given as a subject. So we will substitute this in the parabola equation. So we have 2x square plus 3 times of x plus 5 whole square, which is equal to k. Simplifying this equation, we get 2x square plus 3 times in brackets x square plus 2 into 5 into x plus 5 square, which is equal to k. Opening the bracket, we get 2x square plus 3x square plus 30x plus 75, which is equal to k. This gives us 5x square plus 30x plus 75 minus k, bringing the k term to the left hand side. Now according to the question, the straight line is meeting this curve at a single point. So we have single solution. It means whenever we have single solution, discriminant is 0. So we'll substitute discriminant to be 0. So d is equal to b square minus 4ac is equal to 0. Comparing with the parabola equation, the values of a, b and c are as follows. So substituting these values in the given equation, we get 30 square minus 4 into 5 times 75 minus k, which is equal to 0. 30 square is 900 minus 25 times 75 minus k, which is equal to 0. So 900 minus 25 into 75 is 1875 plus 25k, which is equal to 0. This implies 900 minus 1875, 975 plus 25k, which is equal to 0. Take 975 to the other side, so 25k is equal to plus 975. This implies value of k is 975 divided by 25, which is 39. So this is our final solution. So this question requires both discriminant formula and the use of simultaneous equation, both the skills that we used in the first two videos, for a 5-marker question. Now let's discuss the second past paper question that I showed you in the beginning. We have to find values of x such that fx is less than 9. So substituting the value of fx in the given equation x square minus 4x plus 8, which is less than 9, rearranging everything to one side, we get x square minus 4x minus 1 is equal to 0. So this problem is converted into problem of solving inequality. For the time being, treat this as a equation. So x square minus 4x minus 1, which is equal to 0. Finding the solution by using quadratic formula, we get x is equal to minus b plus minus b square minus 4 times ac divided by 2a. So we get 4 plus minus 4 square is 16 plus 4 divided by 2. So we get x is equal to 4 plus minus root 20 divided by 2. Root 20 can be written as 2 root 5 divided by 2. So dividing 4 with 2 and 2 root 5 with 2, we have 2 plus minus root 5. So we have two solutions. In this case, the parabola is crossing the x-axis at 2 points, 2 plus root 5 and 2 minus root 5. And the coefficient of x square is 1. So this is going to be a upward parabola. And from the inequality, I want to find the part of the parabola where it is negative. It's below x-axis. So between the roots, between the solutions, my parabola is negative. So it means the value of x is between 2 plus root 5 and 2 minus root 5. So here is the summary of this video of all the things that we learned in this video. So first of all, we discussed discriminant, use of discriminant and number of roots. So discriminant is b square minus 4ac. Depending on d is positive, we have 2 roots, 2 solution. If d is equal to 0, we have 1 solution. And if d is negative, we have no solution. Then we discussed how to solve simultaneous equation. So for solving a simultaneous equation, first of all, we will substitute. Then we are going to arrange it, bring everything to one side, make it a nice quadratic. Then we are going to solve this quadratic and then find both the coordinates, x and y coordinates. Then we discussed how to solve quadratic inequality. So to solve a quadratic inequality, these are the steps. First of all, we are going to rearrange, solve for the values of x. Then we are going to sketch it, and from the sketch we are going to see if it is less than 0, then the solution is between roots. If it is greater than 0, then outside the roots. And whenever it is less than equal to 0 and greater than equal to 0, put equal sign in inequality. Equal sign as well using the inequality 2 down the whole course ahead. In the next video, we are going to discuss coordinate geometry, equation of a straight line, gradient, and the concept of a circle. If you haven't watched the previous video on quadratic, please go watch it first. All the concepts in these videos are interlinked. I will see you in the next one.